Okay, hi everyone. My name is Joe Lennon. I am the CEO and co-founder of a company here called Subwoofr, based in Cork. We actually only just began our journey back in September, so we're not even 5 months in. I'm not going to talk to you today about Subwoofr as much as I'd like to. So if you have any interest in what we're doing, we're basically a music tech startup. So if you have any interest in what we're doing, just come chat to me afterwards. We're also going to be hiring at some point this year, not quite just yet, but we're going to be hiring at some point this year. So, if you're a developer, talented developer, designer, whatever, come have a chat with me as well. Or if your boss is here with you, maybe send me an email or something like that. Okay, so what am I going to be talking about today? I'm going to be talking about AWS Lambda. So I suppose just out of interest, before I start, how many people here know about AWS or have used it? Yeah, pretty much everyone, right? How many people have heard of Lambda? Yeah, good lot. And how many are actually using it or have used it? Okay, so not many. Okay, so hopefully, with the exception of you maybe, everybody will get something out of what I'm going to show. So effectively, AWS Lambda is a product that allows you to run backend code without deploying or managing any servers. So essentially what you do is you build your code as a function. You deploy it into AWS Lambda, and then Amazon do some witchcraft in the background that spins up EC2 instances automatically and spins them down for you based on the load requirements of your function. It works slightly differently to a typical backend in that because Amazon manage all of the infrastructure around it for you, there's no server that's constantly running. There's no endpoint to it, so it's a little bit different in terms of how these functions are invoked. Now there's a number of different ways that they are, and I'll go through them in the course of the talk. But I suppose one of the key benefits of Lambda for a developer is that you don't have to worry about managing servers and all of that. So it's very, very useful for somebody in a startup like ourselves. In terms of I actually don't have that many slides. Most of the talk will be me trying to do a live demo. I've rarely seen them work, but I'll give it a go anyway. But I suppose just a few small things about how Lambda works before I dive into it. The first thing is that you can create Lambda functions in 3 officially supported languages, Node, Python 2.7, and Java 8, I think. We're going to see examples of JavaScript and Python functions this evening. I'm not a big Java fan, so we won't touch on that. So they're the 3 officially supported languages. Although it's serverless, it's not really serverless. So it's a bit of a misnomer to call it a serverless architecture. What's actually happening in the background is Amazon are spinning up EC2 instances, running Amazon Linux for you. What that means is that you still have access to a full Linux container effectively, which means that you can actually host out from Node and run like Ruby or Go or some other language if you want to. And if you are using Go, there's a project I'm going to mention in a little bit which might be of particular interest to you. So we'll talk about that in a bit. So they're the 3 officially supported languages. Apparently more are coming soon. I think Go is actually going to be officially supported soon as well. And you can use other languages if you like by hosting out. So I mentioned that Lambda works a little bit differently. So how do you actually trigger or invoke a Lambda function? Typically this will happen from some kind of event in a different AWS service. So if you're using S3 for storing files and objects, then what you might have is as soon as somebody uploads something to S3, it kicks off an event that invokes a Lambda function to do something with that file. And we're going to see an example of that in just a second. Other Amazon services that can be used to kick off Lambda are SNS, Simple Notification Service. We'll see an example of that as well. SES is Simple Email Service. So you can have it so that if you have SES set up to accept inbound messages, then you can allow that to trigger a Lambda function as well. So you could parse the contents of the message and do something based on the contents of it if you wanted. You can use it for scheduled events, so basically use it to do cron tasks. And probably very interestingly, you can now use Amazon's API Gateway product to sit in front of Lambda functions. So you can essentially create a RESTful API without managing any servers. I'm not going to be able to cover that in the time that we have today, but if you are interested in Lambda after today, if I haven't bored you to death talking about it, then that's probably something that you might want to check out later on. And And finally, again, this isn't a complete list. There are many other things as well, like DynamoDB and many other services. But if you have your own user application code and you want to invoke a Lambda function manually yourself, you can do that using the AWS SDK and the AWS CLI as well. In terms of pricing, so because there are no constantly running servers, it obviously works a little bit differently to the traditional AWS EC2 pricing model, which is per compute hour per hour that the server is running. So a Lambda function might only take milliseconds to execute, and then it's done. And how Amazon actually operate the servers completely depends on how much load there is on your functions. So if you have a function that's been invoked over and over again, then it'll reuse the server over and over until it basically gets exhausted. Whereas if you have one that maybe executes one a day or something like that, it'll actually spin it up for a few minutes and then it'll spin it down automatically, and then it'll spin up a new one tomorrow and so on. So there's no concept of a server running for X number of hours. You don't know that. Amazon control all of that in the back end. So how its price is a little bit different. If you're eligible for Amazon's AWS free tier, you get a free 1 million executions or requests, which is quite a lot. And then for every million executions of your function past that, you're paying 20 cents. So it's not that expensive. Obviously, if you have a very big application with lots of Lambda functions, lots of users, concurrency, all that kind of stuff, it does add up quickly, but it's still pretty inexpensive from an execution perspective. The bulk of the costs that you're going to see will be in the compute side of things, which is done by memory consumption and by the amount of time it takes to invoke the function. So they're the two kind of things. If you go onto the Lambda site, it'll give you like a whole list of, if you have a 128 meg function, it'll cost this per 100 milliseconds and so on. The best kind of pricing metric I found somewhere, in some other talk somewhere, was if you have a 1 gig function, which is quite big actually, if you have a 1 gig Lambda function running, for every second that runs, you're looking at, I'm not even going to try and say what that is. I'd say it's like 1,000th of a cent or something like that. Again, which looks really, really low, but it does add up when you do this at scale. But it's still relatively expensive. It's great for somebody like ourselves, where we're at the very start of our journey. This costs us absolutely nothing right now, and Amazon give you pretty good limits within the free tier as well for your first year. So we're enjoying that immensely. And it's saving us from having a load of servers and infrastructure deployed for back-end worker processes. So I said I didn't have too many slides. I do have a couple that I'm going to come back to just to wrap up. But as I said, the bulk, I'm going to just do a couple of demos. And I suppose these demos they're not production code we're using in Subwoofr, but they're not that far away. And they're problems that we had to solve. So hopefully, they're realistic, real world problems that we actually that we encountered. So one of the things that people can do in Subwoofr is they can upload their audio tracks, and then they can sell their music to their fans and so on. So one of the things we didn't want artists to have to do, or their managers or whoever was uploading the files, is to have to upload like loads of different formats of their audio files. So like MP3 and AAC and OGG and FLAC and WAV and whatever. We didn't want them to have to do that. So we made a decision early on that we were just going to ask them to upload, the best quality they could give us. So we said uncompressed WAV files, send those to us, and we'll automatically transcode them down into the various formats for you. Then we also had the issue where if somebody sends us a WAV file, then WAV files are it's quite an old format. There's no metadata attached to the audio file. So you're not going to get like the track title, the artist name, the album name, the cover art, any of that kind of stuff attached to the file. So that meant we couldn't rely on them sending us that information through the file. We had to let them use our UI or import into our platform all that data. So what we decided was that as soon as the transcode process was done, we would then handle attaching the metadata to the track as well. So these are two use cases that we have internally in Subwoofr, and these are two things that we actually do use Lambda in production to achieve. So the first demo is going to be taking a file that's uploaded into S3 and automatically kicking off another AWS product called Elastic Transcoder to automatically transcode that WAV file into MP3 and FLAC. And obviously in production we do it in various other formats as well. We do things like cutting sample 30-second tracks and things like that as well, and you can do all that through Elastic Transcoder. The second demo then would be so once that transcode process has finished, is automatically attaching metadata to the transcoded file, so to that MP3 and that FLAC file which didn't exist before the transcode. So we'll actually listen to an SNS notification that will be fired off by this function as soon as the transcode process is complete, and we'll then attach the metadata. So with the first example, we're going to be using Amazon's web interface to do it. It's pretty simple. And the second example will be, using a text editor and doing it a bit more traditional, a bit more the traditional way. I'll talk about it a bit again later on, but one of the, I suppose, the kind of the weaknesses around Lambda and using Lambda right now is kind of the development process is a little bit, I don't know how to put it, not nice. So I certainly don't like editing code in a browser window, and I don't like uploading zip files and doing things like that. I want kind of a nice deployment methodology or whatever. But I think it's getting there. The tooling is getting there for sure. And one of the example projects, which we actually haven't used yet in production, but I'd say we will very soon. Again, I'll talk about it in a bit. So enough of me rabbiting on. Excuse me, going through notes. I had to take them, or I wouldn't do this properly. But so if you haven't used AWS before, then as soon as you've gotten your degree in how to use AWS, you'll have some kind of an idea of how to use this thing. But effectively, it all starts for this particular demo with uploading files to S3. So I'm going to create an S3 bucket. And if you're wondering if this is the Subwoofr account and I'm giving away the keys to the kingdom, I'm not. It's an old one. So let's see, CorkDev, Lambda. So I've created an S3 bucket called CorkDev Lambda. The next thing I'm going to do is I'm going to set up an Elastic transcoder pipeline that's going to basically take files from there and transcode them into MP3 and FLAC. So I set up a pipeline in Elastic transcoder. I'm going to move pretty fast, so hopefully you can watch back the video if you want to kind of follow this along yourself later on. So I'm going to just create a pipeline, and a pipeline basically kind of defines, the Elastic transcoder task, where it's going to find the files, should it send SNS notifications, that kind of thing. So I'm just going to call this CorkDev Lambda as well. I'm going to select my input bucket, which is CorkDev Lambda. If you were doing this yourself, just note you will need to create an IAM role. If anybody's used AWS, maybe you're like me and absolutely despise IAM because it's absolutely the bane of my life. Anytime I run into any issue in AWS, it seems to be because I haven't created an IAM role. I think, fortunately, in Elastic Transcoder, if I didn't have one there, it would give me a nice option to create one pretty easily. So I'm going to select my output bucket, which is going to be the same as the input bucket, and standard redundancy or standard storage class, which is just the S3 storage class. And the last thing I'm going to do is I'm just going to set a notification. So in order for my second Lambda function to work, I'm going to need an SNS notification to fire as soon as the transcode is completed. So I'm just going to create a new SNS topic here and give it a name of, predictably, CorkDev Lambda. So once I've created that topic, I can create the pipeline. And that's there. I know I have the two pieces of the puzzle I need to transcode audio files. The last thing I need to do is actually put in that function that's going to invoke when people upload something to S3. So as soon as something is dropped into S3, I want to execute a function of code. So I'm going to create a Lambda function. So when you go to create a Lambda function, by default, you'll get this menu of blueprints. And there's some actually really good examples in here of how to use the RESTful, or how to create a RESTful API in front of DynamoDB using the Amazon API Gateway. And some other stuff as well. A lot of things around Kinesis, DynamoDB, and that kind of thing. So, and they tend to be in Python and Node, the examples, but I'm just going to skip that for this particular one. And I'm going to create one called CorkDev Lambda. So in this instance, I'm going to use Node. And effectively, what I'm doing here is I'm just naming the function, selecting my runtime, and then I can paste my code into the browser window directly here if I want, or type it if I want to code in here. So let's see, what do we want to put in here? Am I going to type up a big bunch of code? Probably not. No, I'll use a text expander snippet that I prepared earlier. So again, I'm not going to go into a huge amount of detail in what this code is actually doing, but essentially, one thing to note is that when you use Lambda, you automatically have the AWS SDK available to you. So that means that you can, interact with any other AWS services very easily without having to import any third-party modules and things like that. So in this case, I'm using the AWS SDK to work with Elastic Transcoder. And my function is here, this handler function. So it's the similar node syntax. You can see the exports function there. And by default, when a Lambda function is executed, you're going to get two arguments passed into your function. You're going to get an event object and a context object. The event object is going to have all the information about the event that fired. So in this case, somebody is going to upload a file to S3. So what the event object is going to tell us is going to tell us what bucket they uploaded it to, what the key of the object was, and some other metadata as well. So what we can do then is we can parse that event object and read out that information and use that to do something with that file. So in this case, what we're doing is effectively reading the key. We're setting up some parameters around our Elastic transcoder process. So in here, I'm saying I want the files to be put out into a folder named audio transcoded, and I want to use these presets. So in this case, I have an MP3 preset and a FLAC preset. I do need to make one change here. So bear with me 1 second. What the hell? My keyboard shortcuts are all messed up. Anyway. So I just need to get the the pipeline ID for Elastic Transcoder and plug that in. Okay, so that's going to kick off the Elastic Transcoder job. And I suppose important to note with Lambda functions is that they operate asynchronously. So you're not going to be waiting around for them to complete before you get notification of whether they actually succeeded or failed. So what you have here is the context object is used to indicate whether the function invocation was successful or not. So when I go back out, or when I finish creating this function, I'll be able to show you where you can see how many invocations of the function were made and how many errors they found and all of that kind of stuff. So that's basically the function. So the handler then, in here you define the name of the file that the function is in and the method that you want to execute. So in this case, if you edit it in the browser, it's always going to be called index.js. So it's index and handler is the name of the method in here that I want to execute. More I am role nonsense. In this case, I've already got one, but if you don't have one yourself later on, just select S3 execution role and Lambda will automatically create an I am role for you. And then finally, I get to choose my memory and timeout settings. So when I select a memory setting here, I can select anything from 128 megs right up to 1.5 gigs. It's important to note that when you're billed for invocations of your function, you're going to be billed at the price that you've selected here. So if I select 1.5 gigs and my function only uses 200 megs, I get billed for 1.5 gigs. So generally, like what we did at the start is we selected 1.5 gigs for all our functions, let them kind of run away, monitored them, see, you can see how much memory they're using, and then scale them down afterwards to kind of an acceptable level with a bit of a threshold as well. So in this case, I'm just kicking off a job, so 128 is fine. Just in case I cock up and do something wrong, I'm going to set it to a minute. And I create my function, and then that's done. So the last thing I need to do to get this to work is create an event source. So I have my function, it's in Lambda, it's ready to be invoked, but right now it doesn't know what to look for. Like when should this particular function invoke? So I come in here, I set up an event source, and in here you have a list of the different things that can trigger it. So in this case, I want S3. I want my CorkDev Lambda bucket, and I'm just going to say if any object is uploaded to the bucket, I want to kick off this function. So I'm going to put them into the audio folder and anything with a suffix of WAV. And once I create that, now Lambda is monitoring S3 to see if I drop anything into that bucket, into a folder of audio with a suffix of WAV. So let's go ahead and do that. So right around here is where I probably should fail, and the whole live demo experiment will go horribly wrong for me, but we'll see. So let's see. Prepared some really good music for you. Okay, so that's a WAV file uploaded into S3. And if I just come back out here, okay, there's nothing there yet. Okay, I'm doing okay. So now I have a folder called audio transcoded, and I go in here, and sure enough, I've got 2 files, an MP3 file and a FLAC file. So I think, if nothing else, this probably shows the power of Elastic Transcoder. I mean, to actually do that manually using servers yourself would be a real pain in the ass. I know Mark in Versa certainly knows all about that. But I suppose just to prove that I'm not bullshitting and it actually does play music, I'm going to download that file, play some rockin' tunes for you guys. Hey, it works. Okay, that's enough. Thanks, Coolio. Okay, so that's the first function. Pretty simple, 40 lines of code. Took me about 5-10 minutes, and that's with me talking. So pretty easy. The second one is going to show something a little bit more involved. So when it comes to attaching audio metadata, it's actually not that straightforward. You'd think it'd be pretty easy, but we're going to run into a couple of problems if we try to do it using the same approach we've just used here. The first is that we're not going to be able to use Node for this because there's no reliable NPM module out there that does audio metadata attaching. There's great stuff out there for like reading audio metadata, but not so much for adding it to files. But thankfully with Python, there's a library called Mutagen, which you can use to basically do it, and it's pretty solid. It's got everything you need for like FLAC, OGG, MP3, MP4, pretty much everything. So we're going to use that. Now that introduces a new problem because with editing the code inline in the browser, that's fine when you don't have like any external modules that you need to load in. But if I need to load in a module, like I don't have access to pip or anything like that, or NPM in the browser, so how am I going to load these modules in? So in order to do this, you need to create your functions, as code in an editor, and then upload them along with the modules folder up into Lambda. So to demonstrate that, what I'm going to do is I'm going to create it in my editor. I'm going to package it up, and I'm going to upload it using the command line as well. So Lambda isn't all a web interface. You can do everything at the command line if you want to, and I recommend you do. We create scripts around all of this stuff to kind of automate as much as we possibly can. So let's see, what do I need to do? So, CorkDev Lambda? No, of course it's not. Okay, so what do I need to do? If you haven't used Python, I'm just activating a virtual environment for Python that will allow me to install my dependencies locally here. So I'm going to install, if you're familiar with Node, you'll know npm install, blah, blah, blah. With Python, I can say pip install mutagen. And if I want, so by default, Python's going to install that like into my home folder or somewhere else. So I want to install it locally here into this directory. So I say -t dot. Oh no! I spelled it wrong. Thank you. Right. If that's the only failure I have, I'll be very, very happy. Okay, so mutagen's installed, just to double check, it's there. And now I'm going to create a Python file. So I'm just going to create index.py. And I'm going to edit that. Now, am I going to write 60 lines of code? No, I'm not. So we're going to say metadata. Hey. Okay, so again, there's not a lot going on here. I'm not going to go into it in a huge amount of detail, but effectively, if you're not familiar with Python again, Boto 3 is essentially the AWS SDK for Python. So I think there's a long history why it's Boto 3. I don't know what it is. You can see I'm importing my local module Mutagen, and specifically I'm importing the FLAC and ID3 modules, which I need to attach metadata to MP3 files. And then I have a method called handler, and similar to in my node function, I have event and context being passed in here. So in this case, it's going to be a little bit different. So I'm not getting an S3 file that's been uploaded. In this case, what I'm actually going to look at is I'm going to look at the SNS notification that the Elastic Transcoder job sent off as soon as it finished transcoding those files for me. So it's slightly different. Now, in that SNS message, it's going to include all the information you need again. So it's going to tell you the source file, the bucket that it was in, the object key, and then it'll tell you the output key, where it put the output file, so the audio-transcoded folder and so on. So you can pick everything that you want out of the SNS message. I'm going to cheat a little bit here. So in reality, like we have an API that we use to allow our Lambda functions look up tracks and actually get the metadata for the tracks. In this case, I'm just going to hardcode the data in because I didn't have time to go and create an API. And I have a typo in my metadata. And you can see which track is coming up next. So what I'm going to do then is loop over the transcoded files. So the SNS notification is going to run per job. So even though it transcoded 2 files, that's 1 job, but it'll include all of the output files in the message. So I'm going to parse out some information out of there. I'm going to download the S3 file locally into the Lambda functions instance. And then based on whether it's a FLAC file or MP3 file, I'm going to attach the metadata and save it. And finally, I'm going to upload it back to S3. And very importantly, I'm going to remove the file from the local file system. So, and I'll touch on why that's really important in a second. It's not just because it's good practice. So once I have my function created, how do I get it up to, that's very funny. How do I get it up to Lambda? So firstly, I need to create a zip archive. So I want to include mutagen and my Python file in my archive. So I need to zip it up. So I'm going to create a zip file called attach metadata.zip, and I'm going to include the packages I need. And once I have my zip file, I then need to run this ridiculous function or ridiculous command to upload it to Lambda. Again, in reality, you'd have a script that handles all this stuff for you, and you run that. But effectively what it's going to say here is it's going to create a function with the name attach metadata. This is the reference to the zip file it's going to upload. This is the execution role that it's going to use. This is the name of the handler, so index.handler. So handler is a method in my Python file again. And then this is the timeout that I want, and I'm specifying that it's going to be a Python 2.7 runtime. I'm kind of expecting this to fail for some reason. Nope, okay, cool. So what it's basically spitting back at us is all the information about our Lambda function. So you can see the function name, how much memory is allocated to it, the ARN, which if you were to go on and use the command line to attach the event source, you'd need that as well as your SNS notification, ARN and all of that kind of thing as well. Because I'm a bit short on time, I'm not going to do all that. I'm going to cheat and go back to the web interface to set up the event source, just so I can complete the example. But suffice to say, we've done the hard part. You can do everything else using the SDK as well. But if I just go back to Lambda real quick and come into attach metadata, actually just before I attach the event source, so in here you have a monitoring tab. And this is what I was telling you about earlier, where you can see how many invocations there have been of that function, and importantly, how many errors there have been as well. So then, if I want to figure out what's going wrong, I can view the logs in CloudWatch, which is an awful way to have to debug an application. But as I say, Lambda has its drawbacks, but I'm sure it'll get better over time. So I suppose just to complete the example, I'm going to attach an event source. So in this case, it's not going to be S3, it's going to be SNS. And I want to subscribe to that SNS topic that I created when I set up the Elastic Transcoder pipeline. And with that done, we can see if my second demo works or not. Let's see, S3. So what am I doing? I'm uploading an audio file. So, okay. So that'll upload. Should take a couple of seconds. Okay, so it's there. I'm just going to watch the timestamps for a second. Please. Yay. Okay. So if I went back into Lambda, I'd be able to see the log of that function. But I suppose just to check that, again, I didn't just get lucky. Let's download the file. And I'm just going to use a tool called Kid3 to inspect it. And sure enough, there you have the title and the artist attached into the file. And all that done with no servers and everything else. So I was just going to summarize really quickly, hopefully if I have time, with a couple of things just to watch out for if you do start using Lambda, things that we ran into. And Lambda isn't great for debugging, I'm going to be honest. So try and avoid these things from the start if you can. So I mentioned earlier that, like it's not really serverless. There are servers behind the scenes. And I said to you that, Amazon kind of manage the load of your function, and if they think you need a new sandbox, they'll open up a new sandbox. But generally, if you have a lot of functions or invocations happening sequentially, it's going to have a server that is kept open. So you're operating within one sandbox. What that means is that if you download temporary files onto your server and don't get rid of them, you're going to fill up that server pretty quickly because they only give you 500 megs to work with. If you're dealing with much larger files, then unfortunately Lambda's not going to really work for you. So you can use Elastic Transcoder for video transcoding and all of that kind of thing as well. If you want to attach metadata to video, Elastic Transcoder will actually allow you to do that as part of Elastic Transcoder itself, but for some reason they don't seem to want to do that with audio, probably because ID3 tagging is a total bitch. But so that's one thing that you want to watch out for. There are some limits with file descriptors as well. So again, just clean up after yourself. If you open files or you download files, get rid of them afterwards, after you've uploaded them back to S3 or whatever. Another thing to be careful of is if you use AWS, hopefully you're using kind of the modern approach to AWS, which is to have everything, so all your EC2 servers and your RDS instances and so on, housed within a virtual private container, VPC anyway, whatever the hell it stands for. With Lambda right now, you don't actually have access to VPC resources. So what that means is with RDS, by default, it's going to be deployed within a VPC and it's not publicly accessible. So you're not going to be able to log in with the username and password if you're outside of the VPC. So if you want to use RDS with Lambda, you have to make it public, and that's just a general no-no, so don't do it. But apparently it's on its way. So they promised, I think, at reInvent last year that VPC support is coming to Lambda soon. So that was still about 4 or 5 months ago, so we still haven't seen it yet. But if you do want to get at data within an RDS database, you'd probably be better off creating some kind of an API or something like that that's exposing just what you want to expose rather than blowing a big hole into your database. The other thing as well is, so in my example there, I was lucky I was able to use a library that was precompiled and doesn't rely on a module to be natively built or anything like that. So if you're using an NPM module that wraps around a C module that needs to be built from source when you use npm install, you're going to want to do that on an Amazon Linux EC2 instance, because if you try to do it on a MacBook or on Windows or something like that, what you're going to find is that it's not going to be compatible with Amazon Linux when you deploy it. So that's just another thing to watch out for. Again, it only affects you if you're using things that are going to be built from source for native code on your machine. Yes, the last thing was just with so. As you saw from the examples, the whole process around developing for Lambda isn't really great right now. It's either edit in browser or edit in your code editor and deploy using a command line tool like that with all those messy commands. Apex is a tool developed by a guy called TJ Holloway-Chuck. If you're not familiar with him, if you've used NPM modules like Express Connect or probably one of hundreds of others, that guy's probably responsible for either the whole thing or at least part of it being started. He's now moved on from Node and he's using Go, I think, pretty much exclusively. He's written this tool called Apex in Go. And what this allows you to do is effectively set up a .json file that just defines your Lambda functions for your application, tell it how much memory you want, all that kind of stuff, and then basically go Apex deploy, and it pushes them all up into Lambda, creates all the IAM roles and does all the messy parts for you, creates the event sources and so on. It also gives you a nice way to test your Lambda functions, because one of the things that you'd have to do normally to test a Lambda function is actually put in a test SNS message or fire off a dummy S3 request or whatever. This will do that for you again, so it'll create those dummy requests for you, so you can create your test and you can do it, again, Apex test and put in a little bit of code to run it, so it's quite nice. And the last thing it does is it allows you to use Go functions so it basically creates a node shim that shells out and runs a Go function, again, without you having to worry about doing any of that yourself. So it's a pretty cool tool. As I said, we haven't used it yet. used Lambda and wrote all of our Lambda functions that are there right now before we heard about this, but I'm pretty sure we will be using it pretty soon. So that's it. So hopefully that was somewhat interesting. And if you have any questions, shoot. Thanks. Hey.
So you could almost build like a client-side only app now using an API like Facebook or something like that, but the bad thing is you need your developer API key on the client. Could you use Lambda to kind of thinly wrap another API so that you could write kind of a almost client-side only application? It sounded like they'd spin down your function so that potentially the latency there would be too big to actually.
Yeah, but it's amazing how quickly they actually they warm them up. So with like again, I don't know the internals of how the whole thing works, but I imagine they have like EC2 instances at rest effectively, which they just deploy your code onto and run. So it's not a full warm up. Because I mean, even when you saw the transcodes there or the metadata being attached, it was a matter of seconds. It's not slow. So what actually, I suppose how you'd actually do that is you'd use the Amazon API Gateway tool, which will sit in front of your Lambda functions. In Lambda, you can communicate with any kind of backend. So you can go to DynamoDB or you can go to anything. So you could store sensitive data and all of that kind of thing at that level, which means that you wouldn't have to expose them, and they would be exposed. They would be done completely on the server side. So there's been plenty of articles actually written on creating an entire application, like a full application that's where you put all the tough logic, I suppose, onto the client, and just have this really thin API layer at the back end that's powered by Lambda underneath. So yeah, it's definitely achievable. I haven't done it myself, but. Cool. Any other questions?
The limit on threads or processes, 124, can you request that to be raised, or?
That's tough to Amazon. Again, I've no idea. We haven't run into it, so we haven't had to. I mean, in my experience, Amazon aren't the most approachable people in the world when it comes to these things. But I think, like, I expect what we'll see is things like that. That you'll be able to pay for a more expensive version at some point in the future. But right now, there's certainly no way to do it in the software.
I think those limits, it's like per function invocation. It's not like your functions aren't sharing, your function calls aren't sharing resources, right?
They can be. So it depends on how quickly your functions will execute either concurrently or sequentially. So like we ran into one of those issues where that 500 meg limit, where the first function we created, we didn't delete the temporary files after we downloaded them. Bold us. But we ran into that problem because we were going, what's going wrong? I mean, like, doesn't it spin up a new box every time we invoke the function? And what was actually happening was that temp folder was actually filling up because we were actually running a job to process a load of existing files. So I think it was like 700 or 800 of them or whatever, and it just filled up straight away. So we were getting all these failures. So they do it completely based on, if you run a function and then 2 seconds later you run the function again, they're not going to have actually wound down the server yet, so they'll just reuse it. So it's the file limit, or the file size, or the file storage limit, and the threads and so on is per sandbox, I suppose, which it's kind of hard to see because again it is quite new, so it's like the documentation is really sparse, and you're on Stack Overflow and you're seeing issues like that, and everybody kind of going, what the hell do we do? And eventually somebody figures it out, but it's getting better. That's all I can say.
So with your architecture and how you're designing it, have you thought much about kind of queuing your requests up to Lambda? Because I guess it is async, and if it fails transcoding one of your flat files, like what do you do? So how do you handle errors? And like, I know there is some concept of retries in Lambda, isn't there? But
there is retries in SNS. So it'll automatically retry to send an SNS notification if there's a failure. You can configure it that way. Lambda, I don't believe retries the function. I'm not aware of an automated way to do that within Lambda itself. But what you can do is when a Lambda function executes, you would have seen there the context object that gets added as a second argument to the function. Within that, you can succeed or fail, and you can do like logging, or you can trigger an alert or trigger an SNS notification or something like that to say this failed, and then queue up a retry if you want to.
Yeah.
So again, because you kind of have access to the AWS SDK within your functions, you have the flexibility to do all of that kind of thing. And again, like that particular example, the context.succeed is executed as soon as the job has come, or as soon as the function has completed executing. So if the function fails, you can capture it at that point. Anything else? Cool. Okay. If anybody has anything else.
That's great. Thanks very much, Joe.
Yeah, sure.
So there should be pieces on.